All right, good morning. So your programming test 0, it's this Wednesday, right? So I will give you a little bit more guidance. Well, let's go for some reminder. I can also give you a little bit tips quickly. Okay, so of course your priority, review lab 0. No, that one has been due. You definitely want to review lab 0, part 1 and part 2. And any code example that we discuss, maybe for example in the class, for example static variables, you may want to try them out before the test. Okay, I hope that could be a good hint for you. For example, you may want to go to your lab 0 and then try to extend one of the products, I don't know, it's one of the class there by maybe the ID, which we're going to talk about today, about how to use static variable. That could be one thing you want to try. And okay, that's something. Also, review lab 0, part 1, part 2. I think that's the most important thing. And also the written notes that we talk about, you also want to review them. Your lab number 1, please know that it's due next Tuesday, and then after that, I will also need to release lab number 2. Just make sure to keep in pace with the course. And I also released the mock-up test material. So one thing I will really recommend you guys try. Okay, I'll show you once more. I kind of mentioned that in the announcement. If you go to the lecture site, I would suggest you try to open this link or document from remote lab so you can completely simulate what's going to happen in the test. Okay, so let's say you open this link here from the remote lab, and then go under right here, okay, practice test 0 instruction. If you click on that, so that PDF there is more or less what you will see on Wednesday and for all the subsequent tests. So what you want to do, I'll show you quickly. So go over the programming requirement. That one shouldn't be a surprise, right? So please just make sure obey them. And also that's something. Make sure you know how to export and submit, of course. And then, so there will be a link right here for you to download the starter. Of course, when you simulate, maybe download to your home directory or maybe the desktop. So once you have done that, you can launch the Eclipse from remote lab and import, right? And go from there. At the end or in the middle, you want to try to submit multiple times throughout the simulation. You can set yourself a timer maybe for 60 minutes. So that's how I would suggest. Towards the end, you will see there's also one link right here about under submission section. So you can see there's a link right here. Right? If you click on that, it's going to lead you to the web submit. Right? So I also kind of enable this particular link. You can also try it out to simulate your test. Okay? I just don't want you to waste any time about importing, downloading, and also submitting. You don't really want to waste too much time. You want to be as efficient as possible. You want to focus more on solving the problems on Wednesday. Okay? All right, so please watch out for these. And then make sure you bring your only go to your enroll session if you got accommodation. Okay, so please, you should have received an email from me already. You can just follow my instruction. And make sure to bring your photo ID, right? We're going to check it, okay? And just for Wednesday, because you guys are supposed to go until like 12:50, but I would suggest we end the class a bit earlier. I also need to be there to invigilate your fellow student from section G. So I would suggest on Wednesday, we're going to finish the class around 12:30. And for the missing 20 minutes, I'm going to cover that in section G the next day, and then I'll refer you to the recording, right? Just 20 minutes, right? We will have to do this maybe for all the subsequent tests. I do apologize for the inconvenience, but that's maybe the best way to go. But for those 20 minutes, if you got any questions, just reach out to me. I can definitely answer you for the lecture material. All right, guys, any question about what's going to happen for the course? We good? All right, awesome. So today, I think, so there are still about 4 topics that remain about the OOP review. I will at least cover 2 of them. I think those 2, you definitely need my guidance a bit to have some interaction, have some questions. One is about static variable, and the other one is about the use of this, especially when we got reference aliasing. So for these 2 exercises, I want to go over in detail with you. The remaining 2 topics will be, one thing is about reference type return value, and the last one will be about how you create anonymous objects. I will see if I can talk about them. If I can, I'll do that. If not, we'll see. You can definitely study the slides. It's all the details there. We'll see how they go. All right. Quick recap. So last time we basically did 2 things. We went over this reference aliasing example, right? So just gotta make sure you understand that this particular line can boil down into these 4. 1, 2, 3, 4 parts, right? Just how you understand, and how about and also how to do the tracing, right? For the tracing detail, I wouldn't repeat. Please refer to the recording. It's already on the lecture site. Or if you want to maybe go over the exercise with me again, just reach out. I do have my office hour today, 6 p.m. And we went over also this exercise here from scratch about how you can copy the address of the array, right? Also understand about how the different timings, how the different expressions are going to evaluate into. That's also quite important, okay? And we spoke about aliasing path over here. For example, for this particular object, how many paths do we have pointing to it? You just got to look at how many incoming arrows going to it. You can see we got exactly 1, 2, and 3. So accordingly, you got 3 different expressions pointing to it, right? So that's something you can also try it out. For example, how many alias paths are to this particular object? Also 3. 1, 2, and also 3. But what are they? So that's an exercise for you, right? About aliasing. But we'll do a little bit more aliasing today, just about how to incorporate the use of this. So that'll be the second topic for today. And we introduced this new problem here, just about how we can manage the unique ID for account. Doesn't need to be account. Any class or any object that you want to maintain some unique ID for each one of them, so you can identify them uniquely. You would actually need this kind of solution. If you do not use any global variable or static variable, the best you can do is to explicitly include some parameter. In which case, anyone using your account class constructor, they will have to pass the value over here. So you're really creating some burden on them to really put the IDs uniquely, right? But what if they put something that's duplicated? For example, I got 1 here, I put another 1 here. I wouldn't get any compilation error even. So that's really a logical error that will only appear in the actual execution of your system. That's really something you want to avoid, right? So do review the motivating scenario to see why it has its own limitation. It might kind of work on a very small scale, but to really make things work on a bigger scale, even for this course, for your future, for your lab 1, for example, right? You want to make sure this is properly addressed. The way to solve this problem here is by using something called static variable. To be more precise, we're going to see how the static and non-static variables can work together, right? That's something I'll go over with you. That'll be the first topic for today. And very quick recap. So if you look at just these 2 variables over here, you can see we got L here has no static. So that's called non-static attributes. And G here has the static keyword. So it's called static variable. So for all the non-static attributes, you want to initialize their values in the constructor. And for the static variable, you will initialize their values right away. So the way we visualize is we're going to execute this line right before any objects for counter is even created. I will emphasize that point once more when we get to the solution. Okay? And then we kind of spoke about how you can trace them. So you can see that we kind of set aside a unique memory location called the global counter. I just put a star here just to say it's kind of static. You can put whatever symbol you like as long as you know what you're doing. So there's only a single copy of the G, the global variable, that's being shared among all the instances of counter, right? Number 1. Number 2, for every individual counter object, they have a separate copy of L, non-static. And then we kind of trace about how they can work together, right? So you can go over the details again. But today, we're going to show to you how you can use a mix of the non-static and static variables together to make your account ID automatically managed. Okay, that's something we'll see today, right? Guys, any question about the basic for static? Okay, if I may give you a hint again, the same hints, you may want to try out this example here, okay, before the test. Hopefully that's already explicit hints for you, okay? Okay, let's now take a look at how we are supposed to implement the account ID using static, okay? So this will be on slide number 76. Okay, so I'm just going to show to you 76. So this here is actually going to be a solution that's going to work. However, there will be some little tweaks you may want to do for different applications. I'll mention that briefly today as well, so that you can also try them out. Okay, but let's look at this solution here. Okay, I'll just switch the iPad here. Okay, so first of all, I want you to identify which variables are static and which variables are non-static, first of all, right? So you can see that, to start with, you can see we got 1 static variable right here. And we also got 1 non-static variable, right? So this means this one here is going to be global. It's going to be a unique copy of it. Versus this one here is going to be local. Every account object is going to have a 1 copy for the owner, for the ID right here. Okay? Of course, you can think about this another non-static, which is owner. But this one is not exactly the point for this example. So for now, we don't need to focus too much on that. All right? And one thing to know also right away, you can see that the constructor for the account class here, we got only one parameter. Okay? Let me recall very quickly together. Okay? Here, the ultimate solution, there's only one parameter. On the other hand, from last time, you can see here the account class has 1 and 2 parameters. Right? So what we have gotten rid of is having the user of the account constructor to pass the ID directly. We don't need that anymore. That's a very important point to note. Okay? So let's go back. Okay, I'll write it down as well. So here we got only, so here the list of parameters for the constructor. Not including the ID anymore. So we don't really have to explicitly pass an argument for the ID. We don't have to. Somehow, the static variable is going to do its purpose. We'll see exactly how anymore. And then, so it's not a burden. Not the burden of the user of the account constructor anymore. Okay, let's see that more explicitly. Okay, so I want you to look at these two lines. Okay, this line here, and also, oh, let me just put it a different color. This line here, and also this line here. Right, so these two lines are actually two usages of the new keyword by calling the constructor. Right, so you can see here we got account and account. And here we're only passing the name of the owner, not the ID anymore. And also here, only Jeremy, the owner, but not the ID anymore. Somehow the ID will be managed behind the scene automatically. But we'll see. Okay? So that's one thing to note. Right? And then, of course, the best way to understand about this mechanism is to trace the code, which I'll do. But just before that, look at the body of the constructor here. All right? You can see here we say this.id, which is non-static, is going to be assigned the value of the static variable, first of all, whatever current value it is. And then we're going to increment the global counter so that it can be used for the next object being created for the account. We'll see exactly what's going to happen, right? And then you got to make sure you also assign the owner, right? So that's very simple, actually, mechanism to do. And in the actual test, I'm not saying just for programming test 0, maybe for the future test, you just got to watch out the pattern for the ID. Sometimes it could be a string, which I'll speak about as well at the end. Okay? Any questions so far? Okay, so now the most important thing for us to learn is to see how we can trace the code to see how these two variables work together. All right, let's see that. And remember, if you got static variable, you want to, first of all, allocate some space for that aside. So what I would do is I'm going to say, right before I even create the first object for account, I'm going to call this step number 0, okay? So I'm going to put step number 0 right here, okay? I'm going to set aside some memory over here. And the memory is only for counter, okay? Sorry, for account, okay, right here. So it's going to be for account. And the variable name for static is called global counter. Let me just call it GC, okay? Global counter, and put a star to say it's actually non-static. Oh, sorry, it's actually static, beg your pardon. It is static here. And then what's its initial value? You can see it's 1 here because we initialize it right away. So 1 right here. All right, so far so good. So what's going to happen is this global counter here is going to increment its value after every creation of a new account object. That's something we'll see. All right. Let's now try to execute these two lines one by one. All right, the first one. So if I try to do, let's say, this one here, what I would do is I'm basically creating ACC1, right? It's a variable. It's going to store the address of an account object right here. Okay. So the object type is account. Okay, and then we only got 2 non-static attributes, right? to list. We got the ID here, and also got owner. I'm going to put the ID here, and also I will put the owner right here. And EECS2030B right now is the context objects, this. So what I will do is when I try to call this constructor over here, I step into the constructor, the account, right? Every occurrence of this is going to refer to EECS2030B, as we said earlier. So this right here is going to be EECS2030B. And this over here is going to be EECS2030B. Right? So I'll do the replacement right away. So the first line, EECS2030B.id, which is referring to this local copy. It should be the value for the global counter right now, which is 1. Okay? So I'm going to put 1 here. And then when I go to the second line, the global counter should be incremented by 1. And this makes sense because I don't want the next object to be created to also have the ID 1, in which case I'm going to create some contradiction myself. I want to make sure this is also incremented. Right? So after this, I'm going to increment from 1 to 2. And then finally, I'm going to say this EECS2030B.owner will be owner. And the owner is simply just Jim, right? And the owner is going to be Jim. That's the first object being created. And that one there has the ID 1. Any question? Good? Clear? Okay, let's do one more. Okay, just to reinforce. The second one there is right here, right? The second one there is going to be EECS2. So we are creating EECS2. The variable stores the address of just another account objects. EECS2 account. And then that account object also has the ID and also owner. ID and also owner. And at this line here, EECS2 would be the context objects. So when we go into this constructor here for the second time, every occurrence of this is going to be replaced by EECS2. So this here will be EECS2. This here will be EECS2. All right? Let's execute line by line. If I say EECS2.id will be global counter, EECS2.id will be global counter. Should be 2. Awesome, because if I got 2 over here, you can see the 1 and 2, they are unique. And if the pattern goes on, I will always be guaranteed to have different integer until the max integer, in which case we don't have to worry. Okay? And then, most importantly, we're going to say global counter plus plus. In that way, we're going to increment from 2 to 3. So if I create another third object of type account, it's going to have this ID, right? And then finally, if I say here EECS2.owner will be owner, which will be Jeremy. So it will be Jeremy right here. So after executing these 2 lines, so we got 1, 2 objects, and also the global counter static is now value 3. That's what we have. All right. And of course, if you say EECS1.id, EECS1.getID is going to give you 1. And EECS2.getID is going to give you 2. And of course, they are different. Okay. So 1 and 2 are different. But you can feel free to try another object of type account. It's going to be 3, and etc. Okay. Any questions? I'll take you first. Yeah.
If you make like a new class, like, and then you call new account in the new class, would it be the same?
Yes, you can. Oh, okay, I see what you mean. So basically, the way it's going to work is really based on the constructor for account. So it doesn't matter from which context, from any class, if you try to create a new account object, as soon as you see the new keyword, you know that this block of code will be executed. And this part here will be updated accordingly. So right now, we only got account tester, which is another class, right? If you want to have another class called account tester 2, it's also going to modify the same location as well. Yeah. Question? So do we use the static?
The static keyword when we don't want to track the variable?
What do you mean when we don't want to track the variable?
Because if we create like 1,000 instances, it's like we're not going to know where the variable is at.
Okay, sure. In some way, yes, because the reason that we want to use static is the locations they are set aside. And then we also define under the constructor like a global counter plus plus every time we call the constructor for once. So it's going to be managed automatically. So in that way, we don't really have to track about which number we should really use. Yeah. All right. All right, let me mention one tip for you guys as well. Okay. So you can see here, the ID here is simply just integer to keep it very simple. However, you shouldn't be restricted by that. What if I want to have something like this? Maybe rather than ID, could be, for example, 1, 2, 3, etc. Right? I can easily extend the ID itself to be, sometimes ID in real life can be like a string. It can contain some character. It could be, for example, let's say ID, and then 1. ID, and then 2, etc. To achieve that, all you got to do is change this type here to be string type. And the next question would be, how do I somehow combine the ID as a string with 1, 2, 3 as integer? Right? That could be the follow-up question, right? Okay, that one I can tell you. That one is more like a Java detail, but I can just mention that here. So some alternative for you guys to consider and practice. Okay? I can define, for example, some string and then ID, right? Rather than integer. Let's say ID string. Okay? It could be, for example, some prefix, let's say capital I, lowercase d, and then plus whatever ID value. So this value here could be 1, can be 2, can be 3, etc. But just prefix with ID. So if you try to concatenate a string with an integer in Java, it's going to give you the corresponding string. Okay? So that's a little bit programming detail I can tell you. Okay? You may also want to practice this one here as well. Okay, so that's really about how we can use a static variable. But to really understand the static variable even better, I want to talk about 2 different misusage of the static variable. Right? Let's talk about each one of them. The first one here could be a little bit tricky because you really have to trace the code to see what the problem is. But let's take a look. All right, now I want you guys to take a look at the client class. You can think about the client here is more like a point collector, right? We already got the account, right? And the account may have the ID, right? Which we talked about in the previous page. Let's say the client has an array of account. It's like a point collector has an array of points, similar. And then the number of accounts here, I'm making that static from your lab 0 part 2. Right? We talk about whenever you got array attributes, we have some integer number of products or number of whatever, right? In the lab 0 part 2, we don't really have the static. We don't. But now I'm adding it right here. I can tell you. That's the only change I'm making. And then here in the add account method here, I'm still doing accounts array at the current value of this counter here should be assigned to the argument, right? That's the pattern kind of familiar from lab 0 part 2. And now the question is this going to work by having static counter rather than non-static counter back in your lab 0 part 2? Are they both going to work? Or this one here is not going to work, right? That's the question. I'll just pause for a moment, and then I'll see if anybody would like to give it a try. Even hand waving a little bit, it's okay. I'm going to trace this one as well. Because for this one here, you really have to trace the code to see what might go wrong. Okay? I'll wait a moment, and I'll let you. So guys, at least you should know what the difference is, right? It's really this static keyword I'm adding right here. It will compile, it will run, but the expected output is really what we expect. Okay, I'll take some maybe thoughts. Go ahead. Would you like to share?
I thought it would throw an exception, but it's not going to.
It's not going to throw exception, I can tell you. Somehow, it's not going to throw any index out of bound exception, not for this one here, but the behavior, I can even tell, is already very wrong. Okay, keep it there. Question, thoughts.
I was just going to say, like, it's basically adding more accounts than that's possibly associated with, like, a client. So
when you say, what do you mean adding more accounts?
So let's say you make a client object and you, like, add an account, right? But when you make another one, it's not resetting it. It's to like
Mm,
keep on adding on.
okay, something to do with adding account. Okay. Yeah, go ahead. I'll take one more, and then we'll go over.
My guess is because the variable number of accounts is static, but we're using a this access modifier for the number of accounts to add on to it.
Oh, that one there. Okay, that's good. That's good. That's kind of spot on. However, remember we said earlier last time, if you try, yes, this is static, but if you say this is static, it's not going to give you an error. It's only a warning, which we can somehow afford for now. All right? So guys, if you somehow try to kind of trace the code in your mind, that's a very good sign. But this one is tricky if this is the first time you're seeing this, right? That's why I kind of want you to really see how this can go wrong. Okay, let's trace the code together, right? So let's say you're given some question like similar kind in the exam. You simply have no clue at the first sight. The best way to do is to maybe write a little program yourself to test it and trace it. That's really your safest bet, which is what I'm going to do. All right, let's now do the following, okay? Let's now try to trace this code. Maybe when I start writing, start drawing the diagram, you might be able to spot what's going to go wrong. Okay, we'll see. So we have a class called client tester. And then we're going to have, we just got two clients right here, right? Why don't I just create those two client objects here, okay? So let's say we got Bill and Steve. So we got one client right here, and we got another client here. We got these two. Right? Of course, for each one of them, they're going to have the accounts array, but this one here is going to be set aside, right? It's static. It's not non-static anymore. So what we should do is, before that, we better set aside some location in the memory. So what I'll do is, I'm going to put it here, right? Step 0. Okay? I'm just making that very explicit for you. All right, so what we got is, let's say we got set aside some location, some unique location to be shared. Let's say it's for the client class. And then it's called number of accounts, right? I'll say number of accounts. Static, I'll put a star. Okay, that's just my convention. And then I'm going to put default value, the initial value is simply just 0. Right? So nothing new up to now. One thing you can notice already in the visualization, it's not the case anymore. Like each client is going to have their own NOA. Right? There's only a single copy of NOA that's going to be shared by all the client objects. But don't forget, the NOA is going to be used for indexing into the array that belongs to Bill, and also another separate array that belongs to Steve. How can they share the same copy of the counter? If you kind of notice that, it's already on the right track, right? This is already going wrong, but we'll see how wrong it is. Okay? So let's now create a new clients right here. Okay, let me just create them quickly. So what I'll do is I'm going to say Bill stores some client objects. Okay, so clients over here, I'll say account EECS. And that one there basically just point to an array of certain size. Okay, so it doesn't really matter. I'll just put a few slots here. Okay? And etc. 0, 1, and 2. Are we okay with this visualization, right? That's just for one client objects, right? And I'm just going to copy and paste. Just save a little bit, join. Okay, I'm going to put the second one here. That's going to be for Steve. Do I have, sorry. Is there a way for me to change the color? Okay, if no, okay, I'll just draw from scratch. Okay, sorry about that. So, Steve. So we got Steve. And also a client's objects. EECS. So it's a different array. So you're going to point to an array of certain length. And I'm also going to just put the few slots in the beginning, 0, 1, and 2, etc. Right? So we got two objects here. We got Bill, we got Steve. Okay? So after these two lines. And also we got two accounts. We got ACC1, ACC2. All right. So let me just get these two a little bit smaller, okay? So we do have some space for the account. Okay, so let me put ACC1, ACC2, okay? So we're going to put ACC1 is some array objects. And the attribute here, I don't really need to trace them. I just want to see the object itself. So I can say account. And also ACC2 stores the address of the second account object right here. A account, right? Now the most critical point is this. Let's now trace very carefully. First of all, this line here. I say bill the add account ACC1. What I really want to do, of course, is index 0 of bill should really point to ACC1. Agree? Okay, let's try to see if that's really the case. So you can see the bill here is the context objects, right? So we're going to execute the add account, and ACC1 is the arguments. So that means the ACC here will be ACC1 and also ACC1. And the bill here will be the this. So this will be just bill. And it's actually also implicit this, bill the accounts as well. Right? Let's see what's going to happen. So what we say is bill the accounts. Bill the accounts is referring to this array right here. Add index that correspond to the NOA, which is right here, which is indeed index 0. And then we're going to copy ACC1's address into it. So we're copying the address of this object here, stored in ACC1, into index 0. That's what we're doing. That one there seems to be okay. However, notice one thing here. The second line here is going to increment number of accounts by one. It's going to increment this one here from 0 to 1. Can you already see what's going to go wrong? So now the global counter now is 1. So when we call Steve.addAccount, which index is it going to store into? 1. All right, let's see. So let me highlight the second line here, Steve.addAccount, right? So this one here, the argument is ACC2. So it will be ACC2 and also ACC2. And Steve is the context objects. So it's going to be Steve.accounts. And also it's going to be Steve, the number of accounts, right? Like that. Okay, let's try to trace this. When I say Steve the accounts array, see Steve the accounts array, referring to this array here. At index number of accounts, which is 1. That means we're modifying this index here, right? Right away, without worrying about 0. Okay? So we are actually going to modify index 1 here, and then store ACC2's address to it. That means it's going to point to wherever ACC2 is pointing to. Okay, I'll write it. So it is going to point to wherever ACC2 is pointing to. All right, and then after that, we are actually going to say Steve.number of accounts plus plus. And that one there is going to increment from 1 to 2. Right? So you can see here, what about this index 0? Somehow it's skipped and wasted. So that's a logical error right here. You don't really run into any index out of bound exception, not necessarily, at least for now, but I can already see what's wrong here. Okay, any question? Okay, I got a follow up for you. We will answer this one first. Yeah.
So it would give you a warning? Why would it give you a warning?
Okay, the only warning you will get is over here. When you say this dot number of accounts, which is a static variable, that's the only compilation warning you will get. But that one there wouldn't be enough for you to figure out, exactly this kind of logical error. So this logical error, you can only see that when you try to test it, at the runtime. Yeah. Okay, one follow-up question for you. Okay, Let's say I got another client. Let's say Ian. Just another one. If I say Ian dot add account. Let's say I got another account object ACC3. If this wrong pattern goes on, where would ACC3 be stored in the array for Ian? Yes, because when you try to call this add account method here, you're going to use the current value for NOA, which would be 2. In that case, what you will get is you're basically going to get something like this. It's going to be an array. I'll just sketch a little bit for you. It's basically going to be an array where index 0, index 1 is totally wasted. And then you're just going to store in index 2. And that one there is going to point to ACC3, right? Conceptually. Yes?
Then in this case, using a non-static integer would allow for number of accounts to be an instance variable of each client?
That's exactly right, right? So now, in some way, you can think about this exercise here is let us appreciate like the correct version that we learned from Lab 0 Part 2. Because in Lab 0 Part 2, you actually didn't have this static variable right here, right? But if you accidentally put static over here, so somehow you will need to figure out exactly what's wrong, right? All right, guys, let me recap very quickly, right? This is a tricky one, so you do have some time, to really think about this one here. The correct version should be the number of accounts, which is going to be used for indexing into the local version of the array for each client objects. It should be non-static. However, if I change it to be static, you're going to get a logical error, as I mentioned, right? That's a recap, really. But of course, you're going to see the detailed story. Okay. Any parts you want me to repeat? We're good? Okay. So one more thing about static, and then we'll take a short break. Okay. Another one here is maybe something you kind of ran into if you ever use static variable, maybe back in the first year. You might have seen this one before, but let's take a look. Okay. This one, okay, that will be the last one for static. So let's say we got another class here called bank. And then we got non-static and also got static. We got also method as well. So static method is simply the method where you can just say class name dot method name, similar to how you access static variable, similar. Okay. So I'm going to use the annotation to help you a little bit. I'm going to color everything that's non-static with green. Okay, this one here, and also this one here. So this is a non-static variable. And this one here is a non-static method, meaning that if you actually want to call either this or this, you will need to create some context objects. All right? The next two are static. I got static over here. Also, I got static over here. That tells me if I want to access either this variable here or call this method here, I don't need to create a context object. I don't need to. All I need to say is bank dot next account number, bank dot get info. All right, that's something very important for you to note right away. All right, and then let's look at these two lines. Let me tell you, there's something wrong with these two lines. Specifically, there is a compilation error in either line number 6 or line number 7. Error, not warning, compilation error, which you have to fix. Okay? Can anybody kind of see what's really the error?
I know what the error is.
Huh? You know where the error is? First of all, tell me which line. Line number 7. Okay, what exactly is the error?
Because you're trying to use this in a static method.
This, okay, if you look at this right here, oh, that's okay. Oh, I see what you mean. If you're saying, in some way you're right, you're on the right track. I see what you mean. So your fellow student is saying, now I'm in a static method, but somehow I'm using the this to access something that's non-static. I think that's a complete saying. Yes, in some way you're right. Okay. Anyone else want to share? Yeah, go ahead. That one's okay, actually. Well, remember, okay, we are trying to add a string into some integer. That was totally valid in Java, Okay? So remember, I kind of mentioned earlier about this exercise here. If you got string and integer, if you add them together, it's not doing any arithmetic, just do concatenation. So give it a try. That can be useful for your test or lab. Okay? All right, so the error really comes from right here. All right, compilation error. And let me explain that. Okay, this is also important. And then we'll look at some potential fix. So from here, we're going to get a compilation error. It will look something like this. So give a try on this one in Eclipse. You will see a compilation error like this. They would say non-static variable used in a static context. Non-static variable used in static context. Okay, let's dive that a little bit deeper. So the non-static variable they are talking about right here is this branch name, right? Remember, branch name is non-static. So this is the branch name. Somehow we're using this branch name, of course, using this, right? Used in static context. The static context is really the static method, the getInfo. Right, you can see the getInfo method here was declared as static. So we're using some non-static variable inside a context or a method that is static. That's what the compilation error is saying. It's an error. Inside something, inside a method that's static, you have to use static only. That's a rule. But now we want to see why you cannot use something that's non-static. Okay, anybody see the reason before I talk about it? Why would this not be okay? Why can I not actually say this branch name inside something that's kind of static?
Branch name is like based on the specific bank object.
Context object, yeah.
Object, but this method is going to be called just for like the general class bank.
Yeah, that's exactly right. Yes, thank you. Yeah, I think your fallacy was exactly spot on, but I'll just repeat that and write it down. Okay? So to really understand this one here, you want to think about how exactly can this method be called, right? So expected usage. So expected usage. We can say bank, the class name, dot getInfo. Right? Because the getInfo here is declared as static. However, the bank over here is not really a context object. Not a context object, just a class name. So you can think about conceptually, it boils down into something like this. If I simply replace this over here just by bank, what we're going to have is the bank dot branch name. This is where the error comes from, because branch name over here is non-static, meaning that we're expecting some objects that's being created, but the bank here is not an object. Right? So that's why it's a compilation error. Right? You can also look at the slides. I also kind of explain that in the more textual form. But this is really how you can understand it. The way to understand this is inside this static method here, the way the static method can be called is by using the class name dot method name. So we don't have any context objects. But here, the non-static variable does expect some context object, but we don't have it. So it's compilation error. Right? Quickly, a few minutes, and we'll definitely take a break. How do we fix this? There are two ways to fix this. Right? So I'm going to talk about both of them, okay, quickly. And to go for either fix, well, both fixes are going to work programmatically. However, one of them may not be a good design. Okay? Let's talk about two different fixes. Okay? So I'm going to talk about fix number one, fix number two. So fix number one and also fix number 2. We know that what's really wrong is this line here. There's one here, and this one here. That's where the compilation comes from. Okay, fix number 1. We know that referring to this non-static variable is causing the error. Why don't we just remove its reference? Just don't use it. Okay, so fix number 1 is simply just remove the usage of non-static variable. And what's the consequence? The consequence is when you actually say get info over here, you are just going to return about how many accounts you have created so far. That's a global counter. That's all you get. Okay? You don't really have that branch name anymore. So that means return the number of branches only. Okay? Just this reference here. Okay? That's account number, just that one. Okay, that's a fix number 1. And fix number 2. Let's say I really want to refer to this. So I change the branch name to be static. That's going to work too, compilation-wise. Okay? So if I say branch name here, I will simply make this branch name here static. So I will simply say private static. In that way, it is okay to use. A static variable here. Right, 2 fixes. Fix number 1 might be better. But why is fix number 2 worse? Right? If you actually make branch name static, what does that mean? That means there is only a single branch name for the bank. But in reality, we may have a branch in Mississauga, we may have a branch in North York, we may have a branch in maybe St. George, etc. So the branch name here is not really meant to be unique or meant to be global. So design decision here should be, the branch name here should be instance specific, not really a global one to be shared. Right? There's more like a justification about why fix number 2 is not the way to go. Okay? Okay, not good design. Because the branch name should be instance specific. Because branch name should be instance specific. Right? All right, so these are the 2 misusages for the static variable. I think they can somehow strengthen your understanding a bit, right? So do look into them. All right. Question, go ahead.
I guess for the second one, maybe to make it more complicated, but we could make like a global static array of like the strings for each branch.
Yeah, feel free to definitely extend the example if you wish. I'm just trying to say, let's say we don't want to add any more variable. So that's how we keep it, right? Just keep it simple. Good. Okay, guys, thank you. And then let's say we'll take a short break, and then we'll talk about maybe the second one about using this. You also got a question? Yeah, sorry, I'll answer that quickly.
I was going to say, what if you want to have a method that gives you branch name and also the number of account numbers?
Yeah, of course, in that case, if you want to, let's say branch name stays to be non-static, you would just have a non-static method to return the branch name. Just another method, yes, that's correct. You just cannot really use a non-static inside static. That's the main point. Okay. All right, so please get your iClicker ready. Let's take a quick attendance and a short break. Okay. All right, so we got about roughly 26 minutes. I think it's good. At least we can talk about the second one in detail. I think the second one is very important. You definitely need some guidance from me. So I can also give you some highlights as we go. And for the remaining 2 topics, I think that those are the ones you can definitely just review on the slides, okay, before the test. So let's talk about the second one. Okay. So for the second one here, we're going to see how we can use the this keyword. So the previous usage for the this keyword is to see how we can break through the variable shadowing. But now we're going to use it for a slightly more OO way, right? It's actually a more interesting way to use the this keyword. Okay, let's see. All right, we're going to assume that we have a class called person. Okay, let me just go there directly. Okay. And in the person class, we're going to define a method called marry. We want to somehow marry one person to the other. Okay, let's see how we can achieve that. Okay, for now, let me just put down the declaration for the attribute for the person class. So you can see that we got a class called person, and we got name, and the second attribute. Oh, by the way, there's no static right here. So static is not a focus here, just non-static. Okay, so we got person class, and also we got a name, and we got another attribute called spouse. Okay, a person may have a spouse, but of course, the spouse field may be null if the person is still single, right? That makes sense. And the type for the spouse is just another person. Okay, you can see here we got some match right here. The type right here, person, matches the type of the same class. So this is also allowed in Java. Actually, this is not uncommon in OOP. So just a little bit look ahead. When you actually get to, for example, 2101, maybe next turn about data structure, when there's one class called linked list, in which case you have to use this kind of type, right? Just look ahead. But we don't really cover that in this course. So whenever you have, for example, a type of the variable matching the current class right here, right? You can see the same person here. We call that the recursive type. That name just for your information. So this is something called recursive type. Right? So the type here just refers to the current class itself. It's called recursive type. Okay? And then when we first create a person right here, right, we only pass their name. And then we don't really pass their spouse, for example, right? So that's by default. When we first create a person, they're single. The spouse should be null. We can make a note right here. So you can think about when a person is created, spouse equals null as default. Okay, because implicitly we don't really assign anything to the spouse. So it's as if it's assigned null. What we want to do now is to define a mutator. Doesn't return any value here. It's called marry. We want to marry the current person like this to the parameter, another person called other. Right? That's what we want to do. Okay? And let's say, of course, we're going to somehow do a little bit error handling to say, for example, you cannot really get married if you're already married. You got to be a single person, right? Let's say that's the only rule we want to follow. Okay? So I just want to show you the whole flow about designing this particular method. So rather than trying to program right away the method that's in here, I want to kind of show to you maybe sometimes, let's say in the lab or in the test, if you're not exactly sure how to implement a particular method, you may just want to create some example yourself. For example, right here, I'll show you how to do it. Create some concrete example and try to look at how things are really changed in the diagram. And then from there, you will be somehow reverse engineer about how the method should be implemented right here. Okay, that's what I would do. Okay, I would say let's now try the step number one. We will consider these two persons. Later we got Jin, and also we got Elsa. All right, hope I'm not embarrassing anyone in the class, Jim or Elsa, right? If yes, I'll definitely change the name here. So we got Jim and we got Elsa here. And by default, both of them are single, right? Because the constructor here does not assign any spouse to them, only the name. So let's visualize right away for Jim and Elsa. So let's now, first of all, we got Jim stores the address of some person objects right here. And every person has two attributes. They got a name, they got a spouse. Okay? So we have the name, and also we have the spouse right here. And the name here is simply just Jim. And spouse, by default, is going to be just no spouse, undefined. So the address does not store any person address just yet. So here, I'm just going to say it's null. Okay, so that's what this line would do, okay, by creating Jim. And similarly, when we execute the second line for Elsa, right, just another person, Elsa, different person. So we can say Elsa here stores the address of another person object, right? Just another new keyword, so just different person objects. So we got person here, which also has two attributes. Has the name, has the spouse. The name and also the spouse. And the name here is Elsa, right here. And the address will be just null. All right, so far so good, okay. And of course, our final goal is to see how we can implement this method here so that it's going to marry not just Jim and Elsa, but any potential inputs, right? You want to program in such a general way. It's not going to be very specific to any input values. That's our goal. But for now, let's focus on this example right here, okay? So let me highlight this one here. Since we are dealing with OOP, you always want to see what is the context objects, because we got Jim and we got Elsa, right? So you can think about Jim here is the context objects. And Elsa here is the arguments. So you can think about Elsa here kind of correspond to the other right here, right? The other can be Elsa, maybe can be Mary, can be any person, okay? And Jim here is going to be whatever this you actually refer to inside the Mary method, right? We are trying to somehow make this Jim more generalized. You would simply say this inside the Mary method. But before we even get there, let's see what would be the expected changes if we say Jim.Mary Elsa. That's something we want to see, right? Diagrammatically, if I say Jim.Mary Elsa, what that's going to do is, first of all, Jim.Spouse, rather than storing null address, it is going to store the address of Elsa. So the spouse field is going to point to Elsa objects. Symmetrically, the Elsa object here, the spouse field, is not going to store null here anymore. Instead, it's going to store the address of the Jim objects right here. So there are two changes we have to make. Number one, we have to make sure Jim.Spouse should be equal to the address that Elsa is storing. Symmetrically, Elsa.Spouse should also store the address that Jim is currently storing, symmetric, right? Assuming that both are single, of course. All right, so that's a diagram change. And let's make it one more intermediate step before we get to the program. Let's see exactly the code that we got to write. Okay, I'm going to write down. So that means we're going to get something like this. So think about this is number one. This is number two. So number one, Jim.Spouse. Should be assigned Elsa. And number two, right here, Elsa.Spouse is assigned Jim. Right? So these are the two variable assignment. That one also should not be strange to you. That's also something similar to what we said. Right? All good. So we know exactly what should be changed on diagram and what we should write as Java code. But that's very example specific. It's only specific to this particular example. We want to make it general inside the method. Inside the method, you simply just cannot say Jim, for example. Jim doesn't exist in the scope. There's no Jim. Right? So that's why the identification of the context object and also argument is so important, right? So inside the context or scope of this method, when I say Jim here, is really the context object this. Agree? Okay? So the way to make it general is, think about the Jim here is the context objects. Or it is the this. And the Jim here, over here, is the context objects. This. On the other hand, alpha over here is going to be the parameter other, right? Because alpha actually is in the inside, inside the parenthesis, passes input. So the alpha here is going to be the parameter other. And alpha right here is other. Right? You can see that relation, right? All right, so now we are ready. So you just got to make sure, rather than using gin, alpha, we're going to use the this and other inside the method here. Okay, let's write it down. Okay. So that means number one here is going to become this dot spouse is assigned other. And the second one there is going to become other dot spouse is assigned this. This is so important because this might be the one, if I tell you what to write at first, you might be a little bit confused about why we're using this on the right-hand side as the assignment. Now you know. The reason is we want to make sure alpha, the spouse, is assigned to Jim. And Jim, in this case, just corresponds to the context objects. And the context object is simply just this, right? Okay, so far? So let me recap what we have done so far. So sometimes very often, the method itself may not be so easy to think about how you can implement it generally. The best way to do it is you somehow try to create some examples and try to look at some example usage of the method and look at the context objects and look at any argument objects there and see how they are somehow related to each other. Maybe in the diagram and also in some concrete Java code. And then from there, you can turn this particular example here into context objects and turn this example here into other, the parameter. And then you can somehow reverse engineer back to the code you should write. All right? So this one here is good. It's definitely correct, part of it. But the problem is, what about this kind of situation, for example, right? Let's say if we have this. Let's say Jim is person, and then we got a name here, we got a spouse here, and let's say Jim currently is married to Mary, let's say. Okay, let's say we got the name here, and we got a spouse here. Let's say it's Mary. So spouse here and the spouse here. You can think about this as actually after Jim dot Mary. To really establish this marriage here, these two lines will work perfectly. But the problem is, when we actually try another line, if I say Jim dot Mary Elsa, that's where the problem might go. Let's say we assume whenever you want to marry a person to another, both of them got to be single, right? We can call this maybe illegal, when one of them is actually not single, right? So if you actually try to put Elsa over here, and then the objects, and you're trying to say Jim is going to marry to Elsa directly without first, for example, getting divorced, right? That should really be, the way to go. I'm just saying this is a scenario we haven't really covered just yet in the code. So we should do some conditional to say we only try to make make these two changes if the marriage is legal. Okay, so let's talk about it. We want to make the code more robust. Let's sketch the idea a little bit here. So I'm going to make it conditional. I'm going to say that I will only try to do, I'm going to say if some condition here. And then I will actually I will do these two lines if the condition here is true. Otherwise, else part here, there should be some certain error. The error here could be maybe I simply do nothing. I just don't really allow the marriage, just do nothing. Or maybe I can throw some exception, which we will talk about after the OP review, right? Or to put error here, just a placeholder. You will learn about how to throw some exception later. And here, this Boolean condition here is simply to say the marriage is legal. The marriage is legal. Right? But that should be in Java code. So what should we write, right? To really write this Boolean condition. So let's set this aside. Okay? I'm going to put the condition right here. Any suggestion about what we should write is a Boolean condition here to make sure we only try to change the spouses for both persons if the marriage is legal to do so, right? Go ahead. Okay, that's good. I like that. First of all, we got to say this dot spouse equals no, right? Double equal, right? First of all. So before we can let Jim get married to somebody, currently the spouse must be no. That's one thing. But what about Elsa? Other. They should be single too, right? Right? What should we write? How should we write it? It should be a single Boolean condition, right? Not rather than two separate Boolean conditions. Go ahead, please. Yes, I agree. Thank you. Yeah. So it'll be something like this. You may want to say other, right? That's what we got to refer to. Other dot spouse equals no. Because these are two separate Boolean conditions, we cannot simply put two Boolean conditions inside the if. We're going to combine them. So there are two ways for you to combine. Either you can use the ampersand, or you can use the vertical bar, right? In this case, what should we use? Ampersand, right? Got to be Jim is single and Elsa is single. Okay. All right, so this is the condition you should put inside the if, right? You will see that as well in the slides. All right, guys, any question? I do have some little exercise for you to think about. Question, go ahead.
Is this attribute assignment also called recursive type?
What do you mean recursive type? I would say maybe going a little bit too far, right? So recursive type only to say the fact that the type for this attribute here refer to the current class. That's all we're saying. But the actual variable assignment for the attribute, we don't call recursive something, not really. Yeah, we don't go too far. Okay. All right, so let me make some notes for you, okay? And then we'll see how much time we have, right? So let me just do a little bit of things over here. Okay, several things. So back in your math class, where you learned about disjunction, conjunction, things like that, right? So we got conjunction, right? Or and. And also we got disjunction. Or. And we got negation. Not. So these are the three very important logical operators, right? They do have some kind of the correspondence in Java. So I say kind of means it's not 100%, but for that not 100% issue, we'll address that a little bit later, not today, okay? I'll just show you the correspondence. It's a quick review. So in Java or programming, if you think both conditions must be true, you use ampersand. Or vertical bar, and also explanation mark, right? There's one thing I just want to mention the term. It's something called short circuit evaluation, right? Short circuit evaluation. And this is something I will address maybe a little bit later once we talk about the equals method, a little bit later, okay? Not yet. But if you want to look into this review here, you can feel free. But it's not exactly covered in the upcoming tests, short circuit evaluation, okay? Okay. And I will put some important exercise for you. Okay, exercise. For this marriage example, okay? Exercise. Okay? If you remember the structure of the code right here, we're basically saying if the marriage is legal, then we do the things. Otherwise, error. Let's write this code in a slightly different way to say if the marriage is illegal, then we put some error. Otherwise, we do the right things. Okay, let me write it down. This will be a little bit nice exercise for you to play with the logic a little bit. Okay, so I'm going to put something like this: public void married and person other. Okay, let's now consider the general structure of the code, right? So we're going to say this. If the proposed marriage is illegal, proposed marriage is illegal, then we simply put some error. Otherwise, we're going to do the 1 and 2 right here. So basically, this exercise here just kind of train you to write the same block of code that's going to behave the same way. But the exercise, good thing about it is you're going to somehow, you cannot write the same Boolean condition anymore, right? Because the Boolean condition we wrote earlier is about legal. But now here, this is illegal. So what should we write here? Okay, that's really an exercise. But I'll give you guys some hints, hopefully enough for you to actually go on to complete this one here. All right. So let me start with this. When I say illegal, logically, it's really equivalent to not the case, legal. Agree? Basically, whatever you got earlier as legal condition, like a both person are single, you can simply put parentheses and put exclamation mark. That's going to be the illegal condition you can put. That's the easiest way. All right? However, I want you to dive a little bit deeper. Right? Have you guys heard about something called De Morgan from the math course? Okay? It's a very practical application right here. Okay? So let me just give you one example here. Okay? So De Morgan. So when you say not the case, P and Q. Can you guys help me? What should I write? Not P or not Q, right? Okay, not P or not Q. Okay, another one. If I say not the case, P or Q. Not P and not Q, right? You can think about what we had earlier. This one here is like a P. This one here is like a Q. And we say N. That's a legal condition. Now we want to put the illegal condition right here. It's going to be not P or not Q, right? So I'm going to give you the hints right here. Think about the P here is really the this equals null. And the Q here is really the other equals null. So in order for me to put the illegal condition here, it's going to be not P right here or not Q. You can just change this one to be vertical bar. All right? So that's pretty much the solution. I really want you to try this out. The best way to do this one here is try these two alternative solutions. Maybe try to use a breakpoint debugger to make sure you can really get the right block of code executed when it's legal. All right? Guys, any questions? All right, so let me just say one more thing, and then I'll let you know let you go earlier today. Okay? So we got two more things in the OOP review. We wouldn't have time to really cover them in the class, but they're rather straightforward. You can really refer to the slides because from Wednesday I would like to go on the new lecture. Okay, exceptions. So two more things you can study. One is about how you can trace the reference type return value. You just got to initialize the object, visualize, etc. So you can look at that. I also got some little tutorial video on the slide. You can follow through if you want to. That's number one. Number two is about how you can do anonymous objects. You can basically do objects without assigning that to a variable. You can use it that way. So these two are the small topics. Please study ahead and make sure you complete them. So now we are done with the OOP review, right? So after your programming test 0, we are basically done with the review part for this course. And we'll start covering exceptions on Wednesday. All right? Thank you so much. If you want to drop by my office hour, it'll be 6 p.m. today. Thank you.